Today we are going to be talking all about invertebrates in the intertidal zone. And so this program is geared towards grades 3 through 5. Anyone's welcome to join and watch. Also just want to thank everyone for staying at home and helping to flatten the curve. Please remember, if you do go outside, wear a face mask. This helps a lot. And yeah, we'll get started. So today, what are invertebrates? Big word. We humans are not invertebrates. We are vertebrates. So we have this backbone or spine, also known as our vertebrae, and that makes us vertebrates. But some animals, like octopus, are invertebrates, and they do not have a backbone or spine. And this allows them to do some really cool things. They can fit through holes that are the size of their mouth. So they can squeeze through itty bitty tiny holes and cause a nuisance for some aquarists because they can get out through the tubes. Animals like our sea otters are vertebrates, so they cannot fit through a hole, for one. But yeah, they're more similar to us, where they do have a backbone. But today we're going to be talking specifically about our invertebrates, so animals that do not have a backbone. And a lot of these animals we can find on our ship right out there, the SS Palo Alto. These animals are well adapted and well equipped to live in a really particular habitat known as the intertidal zone. So this zone in the ocean / beach or water or rocky shores is an area where the tide, when it's a high tide, the water is covering this zone, and then when it's a really low tide, this zone is exposed to the air. So when we think about a lot of ocean animals, they have gills, right? They need water to survive. But if they're living in this zone, they also need to be able to survive without water for a little bit of time. So we're going to talk about a lot of these animals, and we can also find them in our tank right here. This tank you can find in the Sea Cliff Visitor Center. And these are the same animals that you can find on our ship out there, or in tide pools, or if you go into a rocky shore area. And that makes these animals really unique because they can survive in this really kind of turbulent and tough zone to live in. So we're going to dive on in and take a closer look at some of these animals. So if you look here, we've got a handful of animals in this tank. We've got our sea anemones, our sea urchins, we've got a lot of algae, some sea stars. Let's take a closer look at another one. We even have a hermit crab somewhere. We'll try to find it later. These animals, because they live in such a tough zone, they have a lot of adaptations that allow them to survive in such a habitat. So adaptations are characteristics or traits that allow an animal to survive in their habitat. This means it helps them survive against predators, or helps them find prey, or even helps them just survive against the elements of their habitat, like wave action. Imagine getting hit by a lot of waves. You have to be pretty strong to stay where you are, or you have to be able to swim around. And even a lot of sunlight. Animals can get sunburnt just like us. So we're going to take a look at some of their adaptations that help them survive in their habitat. So we're going to start off here with the sea anemone. We have our giant green sea anemone. You may notice this one's a bit of a lighter color. If you're out tide pooling or you see these anemones out in the wild, you might notice that they're a bit of a deeper green color. Now, one awesome adaptation that these anemones have is that they actually have little bits of algae that grow inside of them. And this algae helps give them their green color. It also helps them get energy. So this algae kind of acts and gets energy like how our plants and trees get energy, is that they take energy from the sun and they turn that into energy that this sea anemone can use. So that green tint that you see in the sea anemone is from that algae that lives right inside of them. Another adaptation that helps sea anemones survive is that they have these really long tentacles. Now these tentacles have lots of little stinging cells in them, so they can actually sting whatever prey or predators touch them. And this helps them grab onto food and also helps them defend themselves against predators. Imagine you're a predator eating something really harsh, or that's something that stings you. You wouldn't want to eat it, would you? So that helps it survive in its environment, helps it catch food, and helps it stay safe from predators. Last but not least, they also have this other adaptation. It's kind of hard to see right now, but if you look at them in the wild, you might notice that they have rock bits and sand covering the outside of their body, so covering this whole area. And right now you can see some algae growing off of the little bits of rocks that are attached to the anemone. And that actually helps them with sun protection, so it's kind of like sunscreen for a sea anemone. It also helps them keep in moisture and water when the tide is low and they're exposed to the air. It helps them stay a little bit wet so that they don't dry out, because they do need water to survive. So this is our giant green anemone. You can see how big it is compared to our other anemones. This one's the giant green one. Here we have our sunburst anemone. And then we have our little itty bitty strawberry anemones. They all have pretty similar adaptations. You can see that they all have these little tentacles coming off of them, helping them stay safe and catch food. Next, we're going to go on to our sea urchins. Now, sea urchins have some pretty cool adaptations. Go ahead and see if you can think of any. What characteristics are helping them survive in their habitat or their environment? Would you want to eat something that's super pokey and pointy? I wouldn't. So these spines, these purple spines that you see on the outside of the sea urchin, help it stay protected from predators like fish or even sea otters. That would hurt to bite into, wouldn't it? So not only do they have these spines, but they also have tube feet. And these are really long tubular feet that come, come right out of their body all around. And this helps them move around. It also helps things like that shell stay attached to the sea urchin. And it helps them move food towards their mouth. And their mouth is on their underside, so the side that is facing the bottom of the abalone right now. These tube feet help them move around, help them catch food, and bring food to their mouth. Now, they're not chasing after their food because they are herbivores, so they eat kelp. But it allows them to move food towards their mouth. And think about how this ability to be able to attach shells or other things to their body helps them live and helps them survive. What kind of benefit do they get from doing that? We'll come back to that. We'll let you think on that. So let's have a look at their shell. Now, just like their spines, they have this really hard shell as well underneath their spines. So would that be fun to munch into? A hard shell? Or would that maybe hurt your teeth a little bit? It might bother you, so it's a good adaptation, because if you had a soft body, that'd be a lot easier for a predator to eat you than if you had a hard body. So this hard shell helps them stay protected against predators. They also have, on the underside, their mouth. And this is their mouthpiece right here, so it's kind of like their teeth. You can see that they have five teeth plates. 1, 2, 3, 4, 5. And this kind of just peeks right out of here. It sits in this larger hole in the bottom side. And that allows them to gnaw into kelp or even gnaw holes into rocks. So sometimes if you're tide pooling, you might notice sea urchins just resting in a little hole in a rock, and they've actually formed this hole using their mouthpiece. So that means their teeth are pretty strong if they are able to gnaw through some rocks. And that, being able to sit in that little hole and make a hole the perfect size for them, allows them to stay protected against predators. So it'd be harder for a predator to get to them if they're in a rock, sitting in their hole, than if they're out in the open. Now let's have a look at another animal that we can find on our ship or in intertidal zones. Right now we just have the shell of the animal, or animals. As you can see, there's a lot of them growing on the side. This is a barnacle that has even more barnacles growing on the side. And it's like a little crustacean that sits right in here and filter feeds. So that means it grabs little fish or little animals in the water known as plankton. And they kind of just filter through the water, taking in this plankton and eating it. And they have this really hard shell to protect them against predators. Because again, it is harder for predators to bite into a hard shell than it is for them to bite into a soft tissue. One other adaptation that these barnacles have is that they're able to kind of cement themselves to a surface. So they can attach themselves kind of like glue and attach to a surface. And it makes them really durable, and they can withstand a lot of wave action or movement in the water. And you can see how these little barnacles have kind of cemented themselves to this larger barnacle. They're really tightly on there. All right, let's head over back to our tank, and we can have a look at our sea stars. So here we have our bat stars. They come in a variety of colors, and color can even be an adaptation that helps animals survive. How does color help animals survive? Well, it can help them camouflage, or it can even tell predators, if they're brightly colored, it can tell predators that, hey, I taste bad, or I can be toxic or poisonous, so don't eat me. If you look at the outside of our sea star here, you can see that it has that kind of translucent tissue going along the outside, these little fuzziness coming along the outside. And that helps it get oxygen from the water. So they need water to survive because they get their oxygen from water, and they can't get their oxygen from air like we do. So how do they survive when there is a low tide and they're exposed to the air if they need water to survive? Well, these bat stars will actually tightly grasp on to whatever rock they're on or substrate, and this helps them keep water in, especially on their underside. So they're not moving around as much, using as much energy, and they're really just staying still and trying to retain as much water as possible. You can also see that these sea stars have a lot of tube feet. On the underside, you'll see 2 feet running up their arms towards their mouth, which is in the center of their body on the underside. And these 2 feet help them move around and also help them move food to their mouth. Very similar to a sea urchin. These sea stars also have this kind of webbing between their arms. This is a little different from other sea stars you might notice because it's a wider webbing. And actually, sometimes if you flip them over in the wild, you'll find polychaete worms. So these little worms that live under there in their arm grooves, and these worms will actually feed on whatever the sea star leaves. So if the sea star is munching on some food and there are leftovers, these worms will get to feed off of it. So it's kind of like their own little habitat for the worms. A really cool way that sea stars eat is that they actually have 2 stomachs. So one stomach actually leaves their body, it comes out, it surrounds whatever they're trying to eat, let's say a mussel, and then it will start to digest that mussel on the outside of its body, and once it's partially digested, it will then bring that food into that stomach, into their second stomach inside of their body, and finish digesting it there. Imagine being able to digest your food outside of your body. That would be pretty strange, huh? So let's find our last animal. Here it is, our hermit crab. You might see that it has these really long antennae in the front, those orange colored ones. That helps it feel around to sense where it's going and what's in front of it. What are some other adaptations that this hermit crab has? What helps it survive in its environment? You can see that this hermit crab has a shell. Now, it did not make this shell. It actually got this shell from an old snail shell. Very good, Dwayne. Yeah, its shell helps it survive. So this is a common theme that we're starting to see, or a common pattern that we're seeing in a lot of our invertebrates, right? This hard shell. It helps them survive against predators. So if a predator was maybe nipping at this little hermit crab, it might squeeze back into its shell and hide for a little bit until the predator goes away, because it's going to be really hard for that predator to eat through that hard, tough exterior or outside of its body. So like I was saying, it gets its shell from old snail shells. So after a snail has maybe passed away, this hermit crab will move into that shell. So that means as this hermit crab grows, it can't grow the shell. It has to go find a new one to move into. In that little period of time, after it's found a new, bigger shell to move into, it actually has to leave this shell to get into the big one. So that makes it exposed and kind of vulnerable to predators because its soft body that's inside of the shell is exposed in the water, and then it quickly moves into its new home. Hermit crabs also have 10 legs. They're known as decapods. Deca means 10, pods means feet. So they have 10 legs. Right now we can only see a few of them. They've got 2 in their shell that are keeping them kind of attached to that shell and really fit into it. And they have these other 4 pairs out front, helping it move around, maybe helping it defend itself against predators. You can see that they also have pinchers that kind of like help it snap at predators. You can see here, lifting it up. So some help it move it around, some help it defend against predators. These pinchers might also help it eat its prey or whatever detritus or food it's trying to eat. You can also notice that they have 2 eyes right on top. How does having eyes on top help them stay protected? Why aren't their eyes looking down? Why are they on top? Well, their eyes are on top because guess where their predators are coming from? Generally above them. So if you're a fish swimming around, this hermit crab can look up at you to help it stay protected against any attacks. You might also notice that there's algae growing in the shell. How might that algae help it stay protected? That algae can help them stay camouflaged in their habitat. Great question, Dwayne. Do they move into shells of the same species or any type of shell? They do generally prefer the turban snail shells, the hermit crabs that we find out here in the Monterey Bay. So if you're tide pooling or looking into into a rock pool and you see a lot of these black turban shells, look carefully. They might be inhabited by some hermit crabs. So this is our tank here at the visitor center, full of really cool invertebrates. But there's even more invertebrates that you can find on the ship that we don't have here. So up here you can look at our sign. We have mussels. We have aggregating anemones, and these aggregating anemones look very similar to our giant green anemone and our sunburst anemone, but they're smaller, and they generally live in large groups. But they have a very similar color. We also have limpets, hermit crabs, like we saw. Here's the turban snail, where a lot of our hermit crabs get their shells from. The pink short-spined star. My personal favorite, the opalescent nudibranch. Acorn barnacles. Chitons, ochre sea stars. Coralline algae, giant green anemone, sea lettuce, bat star, sea urchin, and goose barnacle. Now these are all invertebrates and plants that you can find on our ship. So none of these animals have backbones. But you can also find other animals swimming through, like other fish, or even other nudibranchs or sea slugs. And a lot of these animals you can also find tide pooling. So as you've learned, a lot of these really awesome invertebrates have these different types of adaptations, some similar to each other, like our sea urchins and our sea stars, which all have tube feet, or our hermit crab and our sea urchin, which have hard shells that keep them protected against predators. These are all adaptations that help these animals survive in their habitat. So these are characteristics that allow them to stay protected against predators or help them find prey, or even stay protected against waves, sunlight, maybe changing salinity, so sometimes the water will be saltier than other times, and these adaptations help them survive. So thank you all for tuning in. We're going to have a live stream around 12:30 about plastic pollution and solutions in our ocean. So feel free to tune on, and that is a public program, so it's open to everyone. And I hope to see you guys later. Bye.